Alright, so the first thing that we want to review is the fact that what happens when you have two square roots that are the same?
They go together.
They go together, and what happens to the square root?
Goes away.
Goes away. So, anytime we have a pair, right there, that would be just a 3. That makes sense, everybody? Hopefully remember that. Now, these are not a pair, right? But you can multiply them back together just to make square root of 15. So remember, this answer now is in simplest radical form. Sometimes they say that. Or it's also called exact because it's not rounded off. Okay? Which I know confuses people when they see the word exact, they think there's going to be more decimals. Actually, with square roots, there's no decimals. Exact means there's going to be a square root left in there. Okay, now this one was not like this one. These were all broken down into prime numbers, right? So remember, if I've got something like this, what I want to do to it first? Break it down.
Yeah.
You can use whatever numbers you want. Okay, I would tell you that if you look for perfect squares, so I'm going to do this a certain way, and then you can still end up with the same thing you had over here. But if you look for perfect squares, you guys agree that 9 is a perfect square? Like, what is the square root of 9? 3. Okay, now I'm going to leave that as 9 just for a second. Okay? Then I'll finish it up the way we normally do. You guys agree that 4 is a perfect square? You guys with me on that? So you can look for perfect squares, and when that happens, you can shorten some steps and know that what is the square root of 9? 3. What is the square root of 4? 2. Now, if you want to keep doing it like you learned the very first way, like in algebra when you were breaking it down, it still is the same answer. It also kind of keeps your pairs together. You guys see what I mean by that? Basically, if you remember that a perfect square of 9 is 3, you're skipping that step and getting right to 3. Okay, a pair of 2's is 2. There's nothing else out there with it. Now remember, you are multiplying, not adding. So this is 6 square root of 5. Okay, does that make sense, everybody? So if you can ever take out a 4, a 9, what would be the next perfect square? What's 4 times 4? 16. Then if you think 5 times 5 is 25, like any of those, it will go in and make your life a little easier. So if you can look for perfect squares, 4, 9, 16, 25, 36, 49, 64, 81, it can make your life easier. Okay? Now, in particular, when I say that, what is special about these two numbers? They are perfect squares. You don't need to break them down. What is the square root of 81? 9. What is the square root of 4? 2, and you would be done. So anytime they are a perfect square, you don't have to break them down. You can just take the square root of them. Same thing over here for the bottom. What is the square root of 36? 6. But now the top, you do have to break it down. Is there a perfect square that goes into it? 9 goes into it, doesn't it? So if I make this 9 and 3, now I can still say I'm going to break the 9 down into a 3 and 3, but what is the square root of 9? 3. So let's get to this point here first, and I want to talk about the last step. Sometimes people get confused on this. Okay, so when I get to here, that 3 cannot go into this 6 because why? Nothing can happen with those two because why? Yeah, like this is not a square root, that is a square root, so they can't go together. But these two are both numbers, aren't they? So essentially that is just like writing this 3 over 6. Will 3 go into 6? 2 times, right? Goes into 3 one time. So this would become 1 over 2, 1 over 2. So that simplifies into square root of 3 over 2. So really there's what number there? A 1, you just don't have to write that. Everybody good on that? Alright, so here's the new thing we're gonna learn today. It's gonna go along with that, but it's gonna be called rationalizing the denominator. Okay, so when we have square roots, you cannot have a square root on bottom. Okay, that's like improper, it's not reduced. So we're going to always try to get rid of it. So the first thing I want you to realize is this. That can be written as that's a square root over a square root. Everybody with me so far? Okay, now, next one I'm gonna say is, on bottom, that square root of 3, I don't want a square root on bottom. So anytime, think back over here, if I wanna multiply by something, what do I need to multiply the square root by to get rid of the square root? The same number. So for instance, like right now, if I put square root of 5 here, what would square root of 5 need to be multiplied by to get rid of the square root? Square root of 5, right? Now, obviously you can't just randomly multiply by numbers when you have a fraction. But what is the one number that you can multiply by that does not change the value? It's 1. So what I mean by that is, if I'm going to multiply that number by 1, really is what I'm gonna do here. But the way I'm gonna do it is, I know I want that to get rid of a square root. So what would I have to put on top, so this is really 1? If there's a square root of 3 on bottom, what has to be on top? The same thing. No matter what the number is, if you put that over itself, do you guys agree it's still 1? Okay, so basically if you kind of cookbook in this, what you're gonna remember to rationalize is whatever I multiply the bottom by, I do the same thing to the top. That's what you need to remember, like the nuts and bolts of it. But what you're really doing is you're multiplying by the number 1, and you just have to pick a special 1. So on bottom, what would happen when I do square root of 3 times square root of 3?
That's supposed to be 5.
Is that a 5?
Yeah.
Yeah, well, this just changed to 5. Well, son of a biscuit eater. I even put my glasses on to try to see it. So all those change to what? Alright, since it was a 5, we gotta use 5. Everybody with me on that? My bad. Same idea. So, maybe it's perfect. Since I have a square root of 5 on bottom, now what has to be on top? Square root of 5. Does that make sense, everybody? That's the main idea. Alright, so what do I have on bottom? I have a 5. Does everybody see why there's a 5 on bottom now without a square root? And that was our whole goal of this, was to get rid of the square root on bottom. Now on top, I can take 8 times 5. I have that, right? So I rationalized it. And unfortunately with these, this will be the pain, but now since I've got a square root of 40 on top, what do I gotta do with that? I gotta simplify that. So I gotta take the 40 and break it down. Somebody says, why did I pick 4? Because it's a perfect square, and that means it's gonna be a 2 and a 2. You guys can keep working that out, but 10 is gonna be 2 and 5, isn't it? It's not a pair, so this is gonna be 2 square root of 10. That's what that 40 becomes. And then that right there is what that became simplified. Okay, anybody think of a question real quick before I go to the next one? Okay, let's look at the next one. Now, I will say this. You do not have to do this first, but it'll make your life easier. If you notice on this problem, what should I hope you notice about square root of 16?
Perfect is 4.
It's a perfect square, so if you go ahead and simplify it now, it'll make your life easier. So what I mean by that is, if I go ahead and make this 4, and then I gotta keep the square root of 3, if I do that first, it'll just make things easier. Okay, so what square root's on bottom? Square root of 3, so what am I gonna multiply the bottom and the top by? Square root of 3. So this square root of 3 and that square root of 3 just become a 3. On top, I have 4 square root of 3, and this was a simple one because there's nothing else you have to do, is there? That can't be broken down. Does 4 go into 3 or 3 go into 4 even? Nope, so you can leave it like that. Okay, on this one, what square root's on bottom? Square root of 2, so I can do that on bottom and top, right? So 2 square root of 2. Square root of 2 and square root of 2 make a 2, don't they? What can I do with these? This 2 and that 2? What is 2 divided by 2? 1, so it's really like they cancel out, isn't it? And now I just have a square root of 2. All right, now first question, before we do this last one. What's different about this one than those other ones we just did? You guys see something? Yeah, like on bottom, what do we have? There's a number and a square root, isn't it? So do you think I need to multiply, do I need to do the 2 also? Or do I just need to multiply by square root of 5? Okay, so remember this. I'm trying to get rid of the square root of 5, right? Everybody agree? So I only need to multiply by that. Okay, so I only need to multiply by square root of 5. Does everybody see why I'm only doing square root of 5? I don't have to do the 2, because remember my goal is just to get rid of the square root on bottom. That's my purpose, right? So I only have to multiply by the square root part. So on bottom, here's what I've got now. That 2 is still going to be there, right? These right here will make just a 5, won't they? So on bottom now I have 10. On top, if I multiply the 12 and the 5, I get square root of 60, right? And then I want to try to break that down so I can make it simplified. Now in this one, if you break yours down, you should get a 2, 2, 3, and a 5. But if you understand that perfect square thing, you make it faster. 4 goes into it, doesn't it? 4 times 15 is 60, right? Yes? You guys agree 4 times 15 is 60? Okay, this is going to end up being 2 square root of 15. If you broke it all the way down to get to that, you'd start with this. Oops, sorry. I got a pair of 2s, that made that 2. 3 and 5, that's not a pair, so it's 15. So I got 2 square root of 15. You think, can I do something with this 2 and that 10? Will 2 go into 10?
Yeah.
Yep, 5 times. So this is square root of 15 over 5. Okay, now the ones at the bottom, now this is what we're going to end up doing on the next lesson. We're going to do some ratios with square roots in them. So look at this one right here. Remember how we said we would cross multiply? So the square root of 3 is times what? The x. 1 is times the 5, right? That'd be our first step. Okay, then Tony, what am I going to divide by here?
3.
The square root of 3. So the square root of 3 is getting divided. So you're going to end up with 5 over square root of 3. Can I leave it like that? This is our new thing we learned today. I've got a square root on bottom, I can't have a square root on bottom, right? So what do I need to do? Multiply the top and bottom by that square root. Now I got it. This one would have a 3 and an x. Equal 15 square root of 6. Now I can divide by 3, right? And on this one, when I take 15 over square root of 6 divided by 3, 15 and 3 gives me that 5. Okay, so today's practice is not very long, so we need to work on that first and go and make sure we understand that, so then we can learn, we're gonna use this on our next lesson.